We are at an incredible moment, witnessing a fundamental shift in how we find information. We're moving beyond just words and into a world where our data search can finally truly see.
I mean, just look around you. Our world is packed with images, videos, charts, and diagrams. It's a visual feast. And yet, the powerful search systems we rely on have, for the most part, been completely blind to all of it, living in a world of pure text. That disconnect is exactly what we're about to fix.
So to really appreciate where we're going, we first have to get a clear picture of the limitations we're leaving behind.
Most of the AI search tools you see today use a process called Retrieval Augmented Generation. You've probably heard it called RAG. It's fantastic at finding text to generate answers, but it has a massive blind spot. When these systems process a document, like a PDF, they basically just suck out all the text and, well, they just throw the images and charts in the trash. All that rich, valuable visual context is just gone.
The solution is a technology that allows AI to connect all these different kinds of data, text, images, video, in a way that's actually meaningful. This is what we call the Multimodal Leap.
At the heart of this leap is a concept called embeddings. The best way to think about embeddings is as a universal language for AI. A model can take literally any piece of content, a sentence, a photo, a clip from a video, and translate it into a string of numbers. We call this a vector, and it perfectly captures the core meaning, the semantic essence of that content. And this, right here, is the real breakthrough. In the old way of doing things, text embeddings and image embeddings lived in completely separate universes. They couldn't talk to each other. But with multimodal models, everything gets mapped into one single unified space. So, the concept of a cat is in the same neighborhood of this space, whether it comes from the letters CAT or from a photograph of a fluffy feline. This is how it all fits together. You have text, images, and video all flowing into one single multimodal embedding model. The model's only job is to create those vector representations that are semantically similar, placing them close together in that shared space. This is what creates a unified understanding across every type of data you can throw at it.
So that's the big idea. But for this to be useful in the real world, it needs to be both fast and accurate. And the way we achieve that is with a really powerful two-stage system.
The process is actually pretty elegant. First, an embedding model acts like a wide net. It scans the entire database at lightning speed to recall a big set of anything that might be relevant. It's fast and broad. Then, a second model, which we call a re-ranker, comes in. Think of this one like a specialist with a fine-toothed comb. It takes that smaller, pre-filtered set and meticulously rescores every single item to find the absolute best, most precise matches. Now, the reason for this two-model approach is all about a classic trade-off. The embedder by itself is incredibly fast, but it's not perfectly accurate. And the re-ranker, well, it's super accurate, but it's way too slow to run on an entire database of millions of items. When you combine them, you get the absolute best of both worlds, the raw speed of the embedder and the pinpoint precision of the re-ranker.
To make things even faster, we can use a really clever optimization called Multimodal Embeddings. It's just like those Russian nesting dolls. We can take just a smaller, nested piece of the full vector to do that initial wide net search. This makes the first step way faster, often with almost no drop in accuracy. It's a fantastic little trick for performance.
Okay, that's enough of the theory. Let's actually see what this technology looks like when you put it to work.
We'll kick things off with a simple text query. We're just going to ask the system to search its database of images for a fluffy cat relaxing.
And there's our result. The system isn't just matching keywords here. It actually understands the semantic meaning, the whole idea of a fluffy, relaxed cat, and it pulls up the perfect image from its database. We just use words to find a visual answer.
Okay, now let's flip the script completely. Instead of using words, this time we're going to use an image as the search query. So, when we feed it a picture of a golden retriever, look what happens. The system returns the most relevant results, and it doesn't care about their format. It finds a text document that's explicitly about golden retrievers, and it also finds other visually similar images of dogs. This is true cross-modal search in action.
So this is much bigger than just a cool demo. This technology is not some academic exercise. It is set to change how we interact with information absolutely everywhere.
The applications are just immense. Think about e-commerce. You could search with a photo of a shirt you saw someone wearing and then just add text to refine your search, like, "But I want it in green." For document analysis, you can finally search for a specific chart or diagram buried inside thousands of pages of reports. And for video, you can instantly find a specific moment in hours of footage just by describing it, like asking it to show me the part when two people were at the ATM.
The big takeaway here is that we are making a fundamental shift from searching by keyword to searching by meaning. This unlocks the enormous amount of unstructured visual data that surrounds us, making our entire world of information not just indexable, but truly understandable. The potential for discovery is just beginning to unfold.